Hi, my name is John and welcome to this online presentation. I will be talking about epoxy asphalt and why it can and will be a viable option towards a more durable pavement. The topics that will be covered in this presentation are as follows. I will first give you a little background information on the companies. I will then give you a brief overview on epoxy asphalt before going through some of the prominent projects that have been completed using epoxy asphalt. Before going into the main segment of this presentation, where I talk about the features and benefits of epoxy asphalt, I will first highlight the key differences between thermoset and thermoplastic modifiers that are commonly used in asphalt today. Next, I will go through the mixing processes and how epoxy asphalt can be used in a batching plant. I will then talk about the pot life of epoxy asphalt. Before wrapping up this presentation, I will also highlight certain limitations of using epoxy asphalt and how they may be overcome. Now, let me give you a quick introduction to our companies. Since its incorporation in 1995, Planet Chemicals has been a value-added distributor and partner representing some of the top manufacturers in the US, Europe, and Asia. We are headquartered in Singapore with offices in China, Malaysia, and Indonesia. Our partner, Ningwu New Materials Development Company, is based in Nanjing, China. They are one of the very few producers of epoxy asphalt in the world. Since 1998, they collaborated with the Southeast University in China to develop an epoxy asphalt formula that rivals even that of the top producers in America. As a result, they obtained various patents and won several national awards along the way. In the beginning of the year 2014, Planet Chemicals signed a partnership with Ningwu New Materials to expand its operations in various parts of Asia and Africa. Let me now give you a brief overview on epoxy asphalt. Epoxy asphalt was first developed by Shell Oil Company in the 1950s. This was during a time of rapid growth in both military and commercial aviation, and this led to ever-increasing wheel loads of aircraft, which posed many structural problems in the design of airfield pavements back then. Moreover, with the development of jet-powered aircraft, pavements were required to have good resistance to high temperatures and the erosive effect of jet blasts. Pavements were also required to be resistant to spillages of jet fuel and hydraulic fluid. So, what exactly is epoxy asphalt? And what sets it apart from other pavement binders? Epoxy asphalt is a tough thermoset modified asphalt that is formed by combining two components, the epoxy resin and the curing agent asphalt. For the benefit of those of you who may not be familiar with the terms thermoset and thermoplastic, I will briefly touch on some of the key distinctions in the later part of this presentation. Epoxy asphalt comes in a set with two types, the epoxy asphalt bond coat and the epoxy asphalt concrete. A hot spray application of epoxy asphalt bond coat precedes the laying of epoxy asphalt concrete to offer optimum bonding strength. At present, there are only two main producers of epoxy asphalt globally, Chemco Systems in the US and Ningwu New Materials, our partner in China. In this segment, I will go through some projects that have used epoxy asphalt. This slide lists some of the prominent projects that have used epoxy asphalt from Chemco Systems. As you may be able to notice, they have been rather active in the US. One of the most prominent projects that have used their epoxy asphalt is the Golden Gate Bridge. This slide lists some of the projects that have used epoxy asphalt produced by our partner, Ningwu New Materials. As you can see, they too have quite an extensive project reference list. Those of you who have visited Shanghai must have travelled along the Minpu Bridge, as pictured here on the right. This cable-stayed bridge stretches over the Huangpu River and links the province of Zhejiang in the west to Shanghai Pudong International Airport in the east. One other notable project is the Hangzhou Bay Bridge, a highway bridge that spans 36 kilometers. There are also various projects outside China that have used NJ epoxy asphalt. A few such projects are the Isansin Bridge in South Korea, as shown here on the right. The bridge was completed in the year 2012 as the world's fourth longest suspension bridge. The Jamuna Bridge in Bangladesh was originally built in 1998 but resurfaced using NJ epoxy asphalt in the year 2012. NJ epoxy asphalt is also currently being used in an ongoing city project in Poland. Now, before I go into the features and benefits of epoxy asphalt, I would think it's important to first have a better understanding on the different types of asphalt modifiers. Modifiers such as EVA, EMA, SBS, and SBR are the most common types of asphalt modifiers used today, and they are classified as thermoplastics. Epoxy asphalt, on the other hand, belongs to a category on its own known as thermosets. So, what essentially are thermoplastics and thermosets? Simply put, thermoplastics have a reversible solidification process in that they soften when they are heated and solidify when cooled, and this is much like a bar of chocolate. Due to its reversible solidification properties, thermoplastic modifiers are most commonly used today as they are relatively easy to work with. Thermosets, on the other hand, can be compared to a boiled egg in that they have an irreversible solidification process. As soon as the cross-linking of a thermoset has taken place, there is no turning back. They become almost indestructible once they cure and cannot be remelted. This video illustrates how differently thermoplastics and thermosets react when extreme heat is applied. The specimen on the left is a thermoset, whereas the one on the right is a thermoplastic. As you will be able to observe, the thermoplastic specimen starts to soften and deform almost instantly, whereas the thermoset specimen remains unchanged. Let's now move on to the features and benefits of epoxy asphalt. The thermosetting properties of epoxy asphalt offer excellent mechanical and chemical resistance. This carries significant advantages over conventional thermoplastic asphalt, where failures are prevalent at elevated load conditions, extreme temperatures, and oil spillages. Epoxy asphalt forms an excellent adhesion to the substrate and resists delamination even at higher temperatures. Featuring a Marshall stability of 40 to 80 kilonewtons, epoxy asphalt is comparatively 5 to 8 times stronger than regular asphalt. The pool of adhesion test in this video illustrates the adhesion strength of epoxy asphalt. In this test, a circular steel stamp that was glued to a concrete block with a layer of epoxy asphalt bond coat is pulled off to test the adhesion strength of the bond coat. As you can see, the point of separation does not occur along the adhesion surface but on the concrete block. The adhesion of the epoxy asphalt bond coat is strong enough to rip out chunks of concrete before giving way. This further substantiates that epoxy asphalt is resistant to delamination. As a result of its excellent structural properties, epoxy asphalt pavements are less prone to polishing. As such, the pavement effectively retains its coefficient of friction over a significantly longer time. Next, with a Young's modulus of 80 megapascals and elongation at break exceeding 180%, epoxy asphalt features a fatigue resistance of 10 to even 30 times that of conventional asphalt. The following video illustrates the tensile properties of epoxy asphalt. As shown here in the test data, the resulting elongation at break is measured at 188%. This means that the epoxy asphalt specimen can stretch to as long as 1.88 times its original length before giving way. Epoxy asphalt resists common failures such as rutting, shoving, and delamination, and has a maintenance-free service life of 30 up to even 40 years. That is more than double that of regular asphalt pavements. Another key feature that places epoxy asphalt as one of the top binder options for durable pavements is its resistance to chemicals. Immersion tests were carried out in various solutions: acid, alkaline, salt, and diesel. These tests revealed that even after being immersed for a period of 24 hours, there were no changes to the physical and mechanical properties of the test specimen. It was also noted that even after a 2-week immersion in diesel, the aggregates from the specimen did not show any signs of loosening. This clearly shows that epoxy asphalt pavements can meet the standard of oil corrosion resistance. Now that we have gone through some of the key features of epoxy asphalt that clearly show how it contributes toward a pavement's durability, I will now go through a few aspects of epoxy asphalt that show how it can be instrumental to a reduction in total construction costs and serve as a greener, safer pavement option. First, due to the outstanding structural properties of epoxy asphalt, mechanical stability requirements of a given pavement can be achieved with less construction material. Studies have shown that strength requirements of a 9 to 11 cm thick conventional asphalt pavement can be achieved with only a 3 to 6 cm epoxy asphalt pavement. This reduction in pavement material will not only serve to significantly reduce overall construction costs, but to also minimize the carbon footprint of projects due to the lesser strain it has on the Earth's natural resources. Moreover, dead weight can also be brought to a minimum. This is especially advantageous when considering bridge projects. Next, because epoxy asphalt can be mixed at a significantly lower mixing temperature as compared to conventional PMA or neat asphalt, the resulting reduction in energy consumption for heating translates to an overall reduction in construction costs. Furthermore, due to the lower mixing temperatures of epoxy asphalt, no harmful VOCs are emitted throughout the construction process. Having gone through the features of epoxy asphalt, now let's take a look at some of its associated benefits. The most prominent benefit is a substantial reduction in both initial costs and project life cycle costs. The significantly longer service lifespan of the epoxy asphalt pavements, with less frequent maintenance and road closures, contribute to a reduction in life cycle costs of the project. Initial project costs are also brought to a low with a reduction in raw material consumption and energy consumed. The use of epoxy asphalt also contributes to non-monetary benefits, such as improving the overall safety and health of construction crew by providing them a safer work environment that is free from VOCs. Moreover, the reduced consumption of natural resources also contributes to an overall reduction in carbon footprint. To further substantiate what we have discussed so far, I would like to quote a snippet from a report jointly put together by the OECD and the International Transport Forum. The report is entitled Long Life Surfaces for Busy Roads. This report concludes that epoxy asphalt has demonstrated its ability to deliver long service lives for pavements. They attribute this to the superior qualities of epoxy asphalt, such as stiffness and insusceptibility to common failures. Now that we have gone through the features and benefits of epoxy asphalt, I will now explain how epoxy asphalt can be used in conventional batching plants with very minimal modification. In this segment, I will also touch on the additional equipment we have to offer that will help you streamline the transition of using epoxy asphalt in your batching plant. The two parts, A and B, are stored in individual storage tanks, where they are each heated to 120 degrees Celsius and pumped into the high-speed epoxy asphalt mixer, where they are mixed according to the specified ratios whilst maintaining its temperature. The mixture is then pumped into the batch plant mixer, where the epoxy asphalt blend is mixed together with preheated aggregates and loaded onto haul trucks that transport the pavement mix to the construction site. It is important to note that the travelling time of the asphalt mixer must not exceed 1 hour, and this is due to its pot life. I will further discuss the issue of pot life in the next segment of this presentation. There are two main types of equipment that we provide: the high-speed epoxy asphalt mixer and the bond coat spray applicator. The high-speed epoxy asphalt mixer controls the flow of part A and B according to their specific mixing ratios, while ensuring a homogeneous mixture is pumped into the batch plant mixer. The bond coat spray applicator is especially important for large-scale projects as it significantly minimizes the workload. The bond coat spray applicator uses a state-of-the-art technology to ensure an even layer of bond coat is applied to the surface. Now, this brings us to the topic on pot life. The pot life is defined as the length of time in which a thermosetting resin retains sufficiently low viscosity for processing. As such, the pot life is a very important factor to take note of, as it essentially lays out the allowable time window allocated for blending, transportation, laying, and compacting of the epoxy asphalt pavement. The three grades of NJ epoxy asphalt we offer have different pot lives. HLN2910 has an extended pot life of 120 minutes, whereas the other two grades, HLN5210 and 8810, have pot lives of 90 minutes. The table shown here entails the pot life and recommended time schedule for each grade. What can be noted here is the difference in time allocated for transportation. Before we wrap up this presentation, I think it would be fair for me to also address some common setbacks of epoxy asphalt. First, due to its pot life, stringent time management and temperature control are essential for the use of epoxy asphalt. This means batching plants cannot be situated further than 45 to 50 minutes from the construction site. A portable batching plant should be used for construction sites that are located more remotely. While some may argue that working with epoxy asphalt may be overly complicated, more than 35 projects were successfully completed over the last 10 years. If they can do it successfully, so can you. To help you get started, we will also be happy to provide on-site technical assistance during the initial phase. And yes, although epoxy asphalt costs more than the regular grades of asphalt on a per unit basis, this cost difference is dwarfed by the benefits and savings enjoyed if you consider the life cycle cost of the project. With this, I would like to thank you for taking the time to watch this presentation. I hope that you now have a better insight into epoxy asphalt and how it contributes to pavement durability. Please feel free to contact me and I'll be happy to answer any questions that you may have.